Hello, so this is my first video in this series of videos on A-level maths. I'm going to be doing lots of videos going through the whole A-level math syllabus for 16 to 18-year-olds in the UK. So yeah, A-level maths is what 16 to 18-year-olds study in the UK. So this is essentially high school maths. And yeah, I'll be doing a series of videos, tutorials on the A-level math syllabus. So yeah, this is the first video in that series, and this video is going to be about the notation that you need to know in the A-level maths course, or notation that may be helpful in the A-level maths course. So yeah, I've got 10 slides here that I've prepared, and we're just going to go through each of these slides and just briefly explain what all this notation means and how it can be helpful in the course. So yeah, this first slide here then, so this is just some essentially inequality notation. So this is all to do with inequalities. So you would have seen these symbols hopefully before at school. So you have this greater than sign, you have this greater than or equal to sign, you have this less than sign, you have this less than or equal to sign. So yeah, A is greater than B is what you would say there. A is greater than or equal to B, that's how you would say that there. A is less than B, that's how you say that. And A is less than or equal to B, that's how you say that. So yeah, I mean, you should all be familiar with that. So this next slide here, so you may not be familiar with some of the notation here. So this like kind of curly E just means, well, it just translates to the terms belongs to or is an element of. So I mean, if we look down here, so what I've written here is X and then this curly E and then this capital R. So this means, or this translates to, X belongs to the set of real numbers. So in other words, X is a real valued number. And this capital R, as you can see there, just means the set of real numbers. So that could be an example of a real number would be the number 1, the number 0, the number pi, the number E. So any number, whether it be rational or irrational, that's what a real number is. But going back up to this symbol here, this n with the double n there, this is the set of natural numbers. So these are called natural numbers, which are essentially the counting numbers. So like 1, 2, 3, 4, and so on and so on and so on. So just a note, some people say that 0 is a natural number. So there is this kind of debate, philosophical debate, whether 0 is or not a natural number. Is or isn't a natural number. So, I mean, in most exam boards, they say that 0 is not a natural number, but there are many professors who say that 0 is a natural number. So just something to be aware of, but nothing major. You're not going to lose marks for including 0 or discluding 0 from the natural numbers. This like Z, double Z there, this is the set of integers. The integers just means whole numbers. So the set of whole numbers. So any whole number essentially would be in that Z set. You've also got this like Q set. So this is the set of rational numbers. So essentially the set of numbers that you can write as a simplified fraction. So for example, the number 1, that's a rational number. The number 10 is a rational number, but also the number a half, the number 199 over 200, the number a negative, the number negative 199 over 200, that's a rational number as well. So any number essentially you can turn into a fraction. And as I mentioned before, the set of real numbers, so fractions, irrational numbers, whole numbers, negative numbers, anything you like, basically. Apart from complex numbers, so to denote a complex number, the set of complex numbers, you use this kind of C notation. But in the A-level course, you don't need to worry about this. This is A-level further maths. Okay, cool. And yeah, as I said before, so X and then this E symbol R just means that X is a member of the set of real numbers. So yeah, that's that page summarized. You've also got like the set symbol, so like this set notation, which you probably would have seen at GCSE. So you probably would have seen before at high school. So this AUB symbol just means that just means the union of the set A and B. So you have two sets A and B there, and with this U symbol in the middle, it just means that we're taking the entire set U combined with B. So basically on a Venn diagram, that's everything contained in A and B as well. So everything in those two circles. So if X belongs to the set of A, U, B, then X is in the union of A and B. So X is an element somewhere in here, essentially. That's just what that means. And then this A intersection B symbol, or this notation, I should say. So this just means, yeah, the intersection of the set A and B. So if X belongs to the intersection of of A and B, then X belongs in here somewhere. It's an element of this set where the two sets A and B overlap. So that's that. A bit more set notation here. So you've got this complement notation. So this A and then this like C, which kind of looks like a power of C. So this is basically everything that is not in the set A. So you're not allowed to be in the set A in this case, but you can be anywhere else in the space. So that's what that means. And then you've got this like opposite slash symbol. So A and then the reverse slash B. It just means everything in A but not B. Everything that's in A but not in B. So discluding or not including B. So yeah, this kind of like moon shape shading in on the Venn diagram. So it's everything in A, but you're not allowed to be in B. That's what this means. So anything in A that excludes B. So in other words, as I've written down here, so the R excluding Q symbol or notation just means the set of irrational numbers. So every real number apart from the integers, well, that's the set of real numbers. So yeah, this A and B, A/B notation just means all of the numbers in A apart from the numbers in B. Okay, so then the next slide here. So this is kind of some useful notation in probability and statistics. So n factorial, well, I mean, this factorial symbol was used for number theory and pure maths too. So n factorial just means n times by the integer 1 less than it, times by the integer 2 less than it, and so on and so on and so on and so on until you get to the number 1 there. And just a little note as well. So 0 factorial, I'll do this in red ink. So 0 factorial is actually the number 1. So just be aware of that. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial would be 12, and so on. Sorry, not 12, my bad, 24. 5 factorial would be 120, and so on and so on and so on. So that's how factorials work. So this is factorials. Sorry, not factors, factorials. Like that. You've also got like this NR in like a vector kind of notation, or this NCR. So N choose R is basically how you say it in English words. So it just basically is denoting the number of ways that you can choose R things out of a total of N things. So if you've got like 10 marbles and you want to choose 5 of those marbles, well, there are 10 choose 5 ways in which you could pick those marbles. So yeah, the formula for that is given by this. So n factorial over r factorial multiplied by n minus r factorial. And that's useful in probability calculations. Then this NPR notation. So this is basically denoting the number of permutations in which you can choose R objects out of a total of N objects. So essentially this, when we choose permutations, the order in which we choose such a permutation does matter. So for example, if you are collecting, or if you're picking, you got 10 cards numbered between 1 and 4, and you want to pick 3 of those cards, the order in which you pick those cards does matter. So yeah, so as I've kind of written here, this NPR formula, or the number that you get, will always be greater than or equal to the n choose R because the order does matter in this case, and so therefore the number of permutations you will have will always be greater than or equal to the number of combinations that you will have when you choose a number of objects out of a total number of objects. So that's all of that. You've also got the summation and product symbols or notation. So yeah, this kind of capital sigma with the n equals I at the bottom and the k at the top. So it just means the sum of this function f of n, where f of n is supposed to be discrete valued, from n equals I up to n equals k. So for an example then, if you want to sum from n equals 1 up to 5 of this n squared function, then this is just the same as doing 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. So you're summing all of the square numbers from 1 to 5, because this function there is the square numbers, where n is an integer. So I should make this clear. This is for discrete valued functions. So discrete valued functions f of n. Okay, and then this like capital pi symbol down here just means the product. So the product of this discrete function f of n from n equals I up to n equals k. So as an example, if you want the product of n squared from n equals, sorry, that's a mistake there. That should be an n, not an I, my bad. Let me just put an n in that. So going from n equals 1 up to 5, and you're taking the product of this n squared function. So this is just 1 squared times 2 squared times 3 squared times 4 squared times 5 squared. So just squaring each number and then timesing it by the next number in the sequence. That's what these two pieces of notation mean. So next on the list, then we've got like these implication symbols, like these arrows, like the equal sign with these arrows at the top or at the tip of them. So this first one just means implies. So as an example, if you've got a statement A, if that statement implies statement B, you would say A implies statement B. So you write something like that. So as an example down here then, so if x is equal to 2, well, that implies that x minus 2 times by x plus 2 equals 0. So that's quite obvious. If x was 2, just substitute that into this formula there, and you get 0. So this statement implies this statement. So that's when we can use this symbol. But if we start with the statement, sorry, I forgot an equals 0 there, my bad again, there should be an equals 0 there. If we start with this statement here, that x minus 2 times by x plus 2 equals 0, that does not imply that x equals 2, because we also have this other solution, x equals minus 2. So that's just something to be wary of in this case. This next symbol here, so like this backwards arrow, so it means is implied by, or it means if. So again, if you've got this x minus 2 times by x plus 2 equals 0, then that is implied by the fact that x equals 2. So just the reverse of what we set up here, basically. But again, x minus 2 times by x plus 2 equals 0 does not imply that x equals 2. It implies that x equals 2 and x equals negative 2 as well. So you can't write this arrow in the reverse direction. And then this final symbol, so like this this double-headed arrow. So it means if and only if, or equivalent to. So in this case, if x minus 2 times by x plus 2 is equal to 0, that's equivalent to saying that x equals 2 and x equals minus 2, because those two values are the solutions to that equation. And if you substitute those two values into this equation, well, you're going to get 0 anyway. So these two statements are equivalent statements. So statement A, if that's statement A, that statement is true if and only if this statement B is true. And so you can use this symbol there to denote that. So that's all of that. And then just a couple of very basic ones. If you ever see someone write a triangle with 3 dots like that, it just means therefore. And 3 dots like this upside down just means because. This next slide here is about functions, so or mappings, I should say, to be more precise. So if you've got a map which takes a set of numbers and transforms it to a new set of numbers, this is called a map, and you can denote it like that. So F and then colon, set A to set B. So yeah, this means that F is a map that takes an element of set A and transforms it or maps it to an element of set B. You also have this notation as well, so x and then like this straight line and an arrow to f of x. So that means that we're mapping the variable x onto the function f of x. So kind of like an example I've done down here. So if you map x onto x squared, well, you're just taking a number x and then you're squaring it. That's all that kind of notation means. This colon with an equal sign next to it just means defined by. So if you've got a function like this one here, you can define such a function in the following way. For example, you could say that f of x is defined by x squared, for example. And yep, so I mean, in this example, again, we've got f, which is a map which takes real numbers to real numbers. So when you put a real number inside this function f, it's going to get you out a real number. That's just basically all that's saying there. So we've got a number, we're going to plug it into the function, you get a real number out of it. And this function has a definition, and that definition is such that f of x is defined by x squared, where x is a real number. So x belongs to the set of real numbers, so x is a real number. That's just our definition of a function. And you may get a question which defines a function in such a way. So yeah, that's a summary of that. And then finally, we've got these symbols here. So I mean, you don't really need to see or need to know these symbols for an A-level maths exam, but it's good to use them. It's useful to know them. So like this upside down A symbol just means for all. This like reverted E symbol just means there exists. And then this symbol with an exclamation mark next to it means there exists a unique blah, blah, blah. So for example, if I translate what I've written down here into English, this means for all x in the set A, there exists a unique y value in the set B such that the function of y is equal to x, where f is some map which takes numbers in the set B and maps them onto numbers in the set A. So that's kind of how you would translate that into written English, essentially. Just to show you an example. I mean, this notation isn't really that helpful. For A-level, you won't really see much of that. But the key notation, I mean, this notation all on this page there is pretty key. You'll see this notation here and there. This notation as well is pretty key. The product notation is not really that important for A-level maths. But again, that's just something to be wary of if you're doing like extra research online. But you will see this summation symbol. You definitely will see that symbol. These symbols will be important in probability. Yeah, again, in probability and set theory, these symbols are intrinsic. These symbols are good to know as well, especially this R symbol is it's everywhere, so you do definitely need to know that. And probably the N and the Z notation as well, you need to know that. You won't really see much of the Q notation. And you will definitely see this E symbol. So you definitely see in your exams something like that down there. X belongs to the set of real numbers, or X is a real number. You could just say it like that. And obviously you definitely will see these symbols everywhere as well. So yeah, that is the first video done. And yeah, the next video would be literally starting the main syllabus for the A-level maths course. So thanks for watching.